Hello. So here we're going to be talking about just an introduction to the unit circle, pretty quick, because this is probably something you're already familiar with, but I just wanted to run through what are some cool things that we can get from it. So what I've done here is I've drawn a nice unit circle. The unit circle is a circle with a radius of 1. So here I have just a triangle drawn, and since the radius is 1, any line from the center directly out would be of length 1. So here we have a nice radius and his length is 1. The other thing I drew here was just some information about SOHCAHTOA, which we know works with right triangle trigonometry. So here I have a blue triangle, which is right. So if I want to look at the sine of this angle, sine is opposite over hypotenuse. So based on my unit circle, sine of theta is the opposite, which I don't know what it is, over the hypotenuse, which is really 1. Right? So sine is equal to the opposite, sine theta. So I'm just going to come in here and say that this guy is represented by sine of theta. All right, same thing, cosine is adjacent over hypotenuse, and because this is a unit circle, my hypotenuse is 1. So cosine of theta is equal to my adjacent over 1. So this, my adjacent, is cosine theta. So that's why, guys, when we're looking at the unit circle, I'm going over cosine. This is on my x-axis. So that's why on the unit circle, x is cosine on any point on the unit circle, and y is sine. Oopsies. Right, because I'm going up or down on the y-axis. Y is sine of theta. Last but not least, we have tangent theta equals opposite over adjacent. And so again, in this case, here we have tangent. The opposite is sine. And the adjacent is cosine. So these are all things that are important for us to remember. Tangent theta equals sine over cosine. On the unit circle, points can be represented by cosine theta, sine theta. And I think I can do one more thing. If I'm looking at this right triangle, I can use the Pythagorean theorem, and this is how I get the Pythagorean identity. The Pythagorean theorem says a squared plus b squared equals c squared. C squared is always my hypotenuse, and so in this case, the hypotenuse is 1. It does not matter the order you go here, so one side is sine. One side is cosine. Oop, let me pick up this little 1 and move them over here. So a squared plus b squared equals c squared. I do want to point out that mathematicians are lazy at not as humans, but I don't think they can be bothered to put these two parentheses. So it is important to note that typically you will see it written like this, that sine of x squared, when it's written like this, is the same as sine squared x. They mean the same thing. All right, so we've got some cool identities here, in particular, your Pythagorean identity, which is right here with the smiley, and we've got tangent is sine over cosine.